Are you ready to ace your next machine learning interview? Or will the bias-variance trade-off leave you stuck in the screening round? In this video, we will cover machine learning interview questions and answers guide for data scientists and ML engineers. Master your machine learning interviews with this comprehensive guide. In this video, we dive deep into 30 essential machine learning interview questions covering everything from supervised learning and feature engineering to deep learning and model evaluation. Make sure to grab a pen and paper to test your knowledge as we go through these real-world interview scenarios. What is the primary difference between supervised and unsupervised learning? Option A. Supervised learning uses in-labeled data, while unsupervised uses labeled data. Option B. Supervised learning requires a ground truth label for training, while unsupervised learning finds patterns in in-labeled data. Option C. Unsupervised learning is always more accurate than supervised learning. Option D. Supervised learning is only used for regression, and unsupervised for classification. The correct answer is B. Supervised learning involves training a model on a dataset that contains both input features and the corresponding correct output labels. The goal is for the model to learn a mapping from inputs to outputs. In contrast, unsupervised learning deals with data that has no historical labels. The algorithm attempts to identify inherent structures, groupings, or patterns within the data, such as in clustering or dimensionality reduction. Which metric is most appropriate for evaluating a classification model with highly imbalanced classes where the cost of a false negative is very high? Option A. Accuracy. Option B. Precision. Option C. Recall. Option D. Specificity. The correct answer is C. Recall, also known as sensitivity, measures the proportion of actual positives that were correctly identified. In scenarios like cancer detection or fraud detection, a false negative, missing a positive case, is much more dangerous than a false positive. Accuracy is misleading in imbalanced datasets because a model could simply predict the majority class for every instance and still achieve high accuracy while failing to detect any minority class instances. A model has high training accuracy but very low test accuracy. What is this phenomenon called and what does it imply about variance? Option A. Underfitting, high variance. Option B. Overfitting, high bias. Option C. Overfitting, high variance. Option D. Underfitting, high bias. The correct answer is C. Overfitting occurs when a model learns the noise and specific details of the training data to the extent that it negatively impacts its performance on new, unseen data. This is characterized by high variance because the model's predictions change significantly with different training sets. High bias, on the other hand, is associated with underfitting, where the model is too simple to capture the underlying trend of the data. In a random forest, how is the final prediction determined for a classification task? Option A. The average of all tree predictions. Option B. The prediction of the deepest tree in the forest. Option C. Majority voting among all individual decision trees. Option D. Using the tree with the lowest Gini impurity. The correct answer is C. Random forest is an ensemble learning method that builds multiple decision trees during training. For classification, it uses majority voting, meaning the class that receives the most votes from the individual Trees becomes the model's final output. For regression, it typically uses the average of the outputs. This bagging technique helps reduce variance and prevents overfitting compared to a single decision tree. Which technique is specifically used to reduce the dimensionality of a dataset while preserving as much variance as possible? Option A. Lasso regression. Option B. Principal component analysis. PCA. Option C. One-hot encoding. Option D. Min-max scaling. The correct answer is B. Principal component analysis. PCA is an unsupervised linear transformation technique. It identifies the directions, principal components, along which the data varies the most by projecting the data onto a smaller number of these components. PCA reduces the number of features, dimensionality, while retaining the maximum possible variance. Lasso can also reduce features via coefficients becoming zero. But PCA is the standard technique for variance-based dimensionality reduction. What is the primary purpose of the learning rate in gradient descent? Option A. To determine the number of features used in the model. Option B. To define the size of the steps taken towards the local minimum of the loss function. Option C. To prevent the model from using too much memory. Option D. To automatically stop the training when accuracy is high. The correct answer is B. The learning rate is a hyperparameter that controls how much we adjust the weights of our network. With respect to the loss gradient, if the learning rate is too small, training will be very slow. If it is too large, the gradient descent might overshoot the minimum and fail to converge, or even diverge. It essentially dictates the step size during the iterative optimization process. What is the main difference between L1, lasso, and L2, ridge, regularization? Option A. L1 adds the square of the weights to the loss, while L2 adds the absolute value. Option B. L1 can shrink some coefficients to exactly zero, performing feature selection. Option C. L2 is only used for deep learning, whereas L1 is for linear regression. Option D. L1 always results in higher accuracy than L2. The correct answer is B. L1 regularization. Lasso adds the sum of the absolute values of the weights to the cost function. This leads to sparse models where some feature weights become exactly zero, effectively acting as a built-in feature selection tool. L2 regularization. Ridge adds the sum of the squares of the weights. It shrinks coefficients towards zero but rarely makes them exactly zero, keeping all features in the model but reducing their influence. Which activation function is commonly used in the hidden layers of a deep neural network to mitigate the vanishing gradient problem? Option A. Sigmoid. Option B. tanh. Option C. ReLU, rectified linear unit. Option D. Softmax. The correct answer is C. ReLU is defined as f x equals max 0 x. Unlike sigmoid or tanh, which saturate at 0 or 1, causing gradients to become very small, vanish during backpropagation, ReLU has a constant gradient of 1 for all positive inputs. This helps gradients flow more effectively through many layers, speeding up convergence and allowing for the training of deeper networks. In k-means clustering, how is the k usually determined? Option A. Using the bias variance trade-off curve. Option B. Using the elbow method or silhouette score. Option C. K is always equal to the number of features in the dataset. Option D. K is determined by the number of iterations until convergence. The correct answer is B. The elbow method involves plotting the within-cluster sum of squares, WCSS, against the number of clusters, K. The elbow point where the rate of decrease significantly slows down is often chosen as the optimal K. The silhouette score measures how similar an object is to its own cluster compared to other clusters, providing a quantitative way to assess the quality of the clustering. The naive Bayes classifier is called naive because it assumes. Option A. The data follows a normal distribution. Option B. All features are independent of each other given the class label. Option C. The target variable is continuous. Option D. There is no noise in the training data. The correct answer is B. Naive Bayes is based on Bayes' theorem. It is called naive because it makes the strong, and often unrealistic, assumption that all features in the dataset are conditionally independent given the value of the class variable. Despite this oversimplification, naive Bayes performs surprisingly well for many complex real-world problems, such as text classification and spam detection. What does an area under the ROC curve, AUC ROC, of 0.5 indicate? Option A. The model has perfect predictive power. Option B. The model is better than a random guess. Option C. The model's performance is equivalent to random guessing. Option D. The model is perfectly classifying the negative class but not the positive. The correct answer is C. The ROC curve plots the true positive rate against the false positive rate at various threshold settings. An AUC of 1.0 represents a perfect model. An AUC of 0.5 means the model is unable to distinguish between the two classes and is performing no better than flipping a coin. An AUC below 0.5 suggests the model is consistently predicting the wrong class. Which layer type in a convolutional neural network, CNN, is primarily responsible for reducing the spatial dimensions of the input? Option A. Fully connected layer. Option B. Convolutional layer. Option C. Pooling layer, e.g., max pooling. Option D. Softmax layer. The correct answer is C. Pooling layers, such as max pooling or average pooling, are used to downsample the feature maps. This reduces the number of parameters and computation in the network, and also helps the model become invariant to small translations in the input image. Convolutional layers extract features, while pooling layers simplify the output of those convolutions. What is the purpose of kernels in support vector machines, SVM? Option A. To clean the data from outliers. Option B. To transform linearly inseparable data into a higher dimensional space where it becomes separable. Option C. To reduce the number of support vectors to save memory. Option D. To calculate the probability of each class. The correct answer is B. The kernel trick allows SVMs to solve nonlinear problems by mapping the original input space into a much higher dimensional feature space. In this new space, A linear hyperplane can be used to separate classes that were not linearly separable in the original space. Common kernels include RBF, radial basis function, polynomial, and sigmoid. Why is it important to perform feature scaling, like standardization, for algorithms like k-nearest neighbors, KNN? Option A. To make the data follow a Gaussian distribution. Option B. Because KNN is based on distance metrics, and features with larger scales would dominate the distance calculation. Option C. To ensure that categorical variables are converted to numbers. Option D. To speed up the training process by reducing the number of neighbors. The correct answer is B. KNN calculates the distance, e.g., Euclidean distance, between data points to find the nearest neighbors. If one feature has a range of 0 to 1 and another has a range of 0 to 10,000, the second feature will disproportionately influence the distance calculation. Scaling ensures that all features contribute equally to the distance metric. Which of the following is an example of a boosting algorithm? Option A. Random forest. Option B. XGBoost. Option C. Bagging predictors. Option D. Extra trees classifier. The correct answer is B. Boosting is an ensemble technique that attempts to create a strong classifier from a number of weak classifiers. It does this by building models sequentially, where each new model attempts to correct the errors made by the previous models. XGBoost, extreme gradient boosting, AdaBoost, and light GBM are popular boosting algorithms. Random forest, however, is based on bagging. In the context of neural networks, what does backpropagation do? Option A. It initializes the weights of the network randomly. Option B. It calculates the gradient of the loss function with respect to each weight using the chain rule. Option C. It acts as a final activation layer to produce probabilities. Option D. It selects the best architecture for the network. The correct answer is B. Backpropagation is short for backward propagation of errors. It is the central mechanism by which neural networks learn. After a forward pass, where a prediction is made and loss is calculated, backpropagation works backward from the output layer to the input layer, calculating how much each weight contributed to the error. These gradients are then used by an optimizer, like SGD, to update the weights. What is the curse of dimensionality in machine learning? Option A. The fact that more features always lead to a better model. Option B. The difficulty of cleaning high-dimensional data. Option C. As the number of features increases, the data becomes sparse, making it harder to find patterns and requiring more data. Option D. The increase in training time as the number of rows increases. The correct answer is C. As the number of dimensions, features, increases, the volume of the space increases so fast that the available data becomes sparse. In high-dimensional space, all objects appear to be sparse and dissimilar in many ways, which prevents common data organization strategies from being efficient. This often leads to overfitting and requires exponentially more data to maintain the same level of model performance. What is cross-validation primarily used for? Option A. To clean the dataset from missing values. Option B. To estimate the skill of a machine learning model on unseen data and ensure the results are generalizable. Option C. To choose between supervised and unsupervised learning. Option D. To speed up the training of a deep learning model. The correct answer is B. Cross-validation, like K-fold CV, is a resampling procedure used to evaluate machine learning models on a limited data sample. The goal is to test the model's ability to predict new data that was not used in its training, in order to flag problems like overfitting or selection bias and to give a more accurate estimate of model performance. Which algorithm is most likely to suffer from the exploding gradient problem? Option A. Decision trees. Option B. Recurrent neural networks, RNNs. Option C. Linear regression. Option D. K-means clustering. The correct answer is B. RNNs are designed to handle sequential data by passing information through time steps. During backpropagation through time, BPTT, gradients are multiplied repeatedly. If the weights are large, the gradients can grow exponentially, leading to exploding gradients, which make the model unstable. LSTMs and GRUs were specifically designed to combat this and the vanishing gradient problem. What is the purpose of early stopping during model training? Option A. To save electricity by turning off the GPU. Option B. To prevent overfitting by halting training when performance on a validation set starts to degrade. Option C. To stop training as soon as the training loss reaches zero. Option D. To ensure that the model uses the maximum number of epochs possible. The correct answer is B. Early stopping is a form of regularization. During training, the model's performance on the training set usually improves over time, but after a certain point, it may start to overfit the noise in the training data, causing validation performance to drop. Early stopping monitors validation error and stops the training process when the error stops decreasing, ensuring the best generalization. Which of the following is a lazy learner? Option A. Support vector machines. Option B. K-nearest neighbors, KNN. Option C. Logistic regression. Option D. Neural networks. The correct answer is B. KNN is called a lazy learner because it does not have an explicit training phase where it builds a generalized model. Instead, it simply stores the training data. The actual work happens during the prediction phase, where the algorithm calculates distances between the test point and all training points. Eager learners, like neural networks, build a model during training. What is dropout in the context of neural networks? Option A. A technique where certain neurons are randomly ignored during training to prevent overfitting. Option B. Deleting data points that are considered outliers. Option C. Removing layers from a network that are not contributing to accuracy. Option D. A method to reduce the learning rate over time. The correct answer is A. Dropout is a regularization technique. During each training iteration, a random selection of neurons is dropped out, set to 0. This prevents neurons from co-adapting too much and forces the network to learn more robust features that are useful in conjunction with many different random subsets of other neurons. In the bias-variance trade-off, what happens as model complexity increases? Option A. Bias increases. Variance decreases. Option B. Bias decreases. Variance increases. Option C. Both bias and variance increase. Option D. Both bias and variance decrease. The correct answer is B. As a model becomes more complex, e.g., adding more layers to a network or depth to a tree, it becomes better at fitting the training data, which reduces bias, error due to simple assumptions. However, this high complexity makes the model more sensitive to small fluctuations in the training set, which increases variance, error due to sensitivity to noise. What is the drawback of using one-hot encoding for a categorical feature with very high cardinality, many unique values? Option A. It creates a very sparse and high-dimensional feature space. Option B. It loses the order of the categories. Option C. It can only be used for binary classification. Option D. It automatically causes the model to underfit. The correct answer is A. One-hot encoding creates a new binary column for every unique category. If a feature, like city, has 10,000 unique values, it adds 10,000 columns to the dataset. This leads to the curse of dimensionality, significantly increasing memory usage and computational cost, and often leading to overfitting. For high cardinality, techniques like target encoding or hashing are preferred. Which algorithm uses the concept of Gini impurity or information gone? Option A. Logistic regression. Option B. Decision trees. Option C. K-means clustering. Option D. Principal component analysis. The correct answer is B. Decision trees use these metrics to determine the best way to split the data at each node. Gini impurity measures the frequency at which a randomly chosen element from the set would be incorrectly labeled. Information gain is based on the concept of entropy. The algorithm chooses the split that results in the purest child nodes. Lowest impurity or highest gain. In a Bayesian context, what is the prior? Option A. The probability of the evidence given the hypothesis. Option B. The probability of the hypothesis after considering the data. Option C. The initial belief or probability of the hypothesis before any data is observed. Option D. The normalization constant in Bayes' theorem. The correct answer is C. In Bayes' theorem, the prior represents our knowledge or belief about a parameter or hypothesis before we see the current data. The likelihood is the probability of the data given the hypothesis. The posterior, the result, is our updated belief after combining the prior and the likelihood. Which of the following is true about the F1 score? Option A. It is the arithmetic mean of precision and recall. Option B. It is the harmonic mean of precision and recall. Option C. It only considers false positives and ignores false negatives. Option D. A higher F1 score always means higher accuracy. The correct answer is B. The F1 score is the harmonic mean of precision and recall. It is used because it penalizes extreme values. If either precision or recall is very low, the F1 score will be low, even if the other metric is high. This makes it a better overall measure of a classifier's performance than a simple average, especially on imbalanced datasets. What is the primary benefit of using batch normalization? Option A. It reduces the size of the dataset to save memory. Option B. It allows for faster training and higher learning rates by stabilizing the distribution of inputs to each layer. Option C. It is a type of data augmentation for images. Option D. It replaces the need for activation functions. The correct answer is B. Batch normalization normalizes the output of a previous activation layer by subtracting the batch mean and dividing by the batch standard deviation. This addresses the problem of internal covariate shift, making the network less sensitive to initialization and allowing for faster convergence and more stable training. What kind of problem does logistic regression solve? Option A. Regression. Predicting continuous values. Option B. Classification. Predicting categorical labels. Option C. Clustering. Grouping similar points. Option D. Dimensionality reduction. The correct answer is B. Despite its name, logistic regression is a classification algorithm. It uses a logistic function, sigmoid, to model the probability of a binary outcome, e.g., yes, no, 0/1. It is called regression because it is a linear model that predicts the log odds of the probability, but its output is used for classification. What is the primary risk of using mean imputation for missing values in a dataset? Option A. It increases the variance of the data. Option B. It can artificially reduce the variance and distort the relationships between variables. Option C. It always makes the model slower to train. Option D. It is only applicable to categorical variables. The correct answer is B. Mean imputation replaces missing values with the average of the available data. While simple, it ignores correlations between features. Because it adds many identical average values, it shrinks the variance of the feature and can lead to biased estimates of relationships between variables, potentially weakening the predictive power of the model. That wraps up our 30-question deep dive into machine learning interview prep. We've covered the core concepts that top-tier companies look for in their candidates. If you found this helpful, hit the like button and subscribe for more technical interview guides. Don't forget to comment your score below. For the complete set of practice questions and detailed study materials, check out the full exam link in the description below.